Hey, what's up, everybody? It's Mr. Cherry. I'm back here again, your favorite math teacher. You know I couldn't leave you alone. So today we are going to be looking at how we can transform the equation y equals 2 to the power of x. And we're going to do this a couple of different ways. So in the first way, what we're going to do is we're going to add some sort of number onto the end of that graph, y equals 2 to the x power, and we want to see how it changes. So what I'm going to do is I'm just going to click on this equation that I've written. And I've already created a slider. So let's set m at 0, meaning if we look at this blue curve here, that is the same as what we started with. Now, I want you to notice what happens as I change the value of m, meaning what happens as I add something to this equation. What happens to the graph? And again, we could think about the same way. If we go back to 0, what happens to the graph y equals 2 to the power of x when we take something away? How does it shift? How does it change? So if you would, just really quick in your notes, write down how changing the value of m changes where this graph is located. All right, students, so next we're going to be looking at how does the graph shift if we change the value of n up here. Meaning, if we take our exponent and we take something away from it, what happens to the graph? And so again, just like before, I've made a slider. And so in this slider, I've got my n value at 0. So I'm starting at the parent function. And now as I make n positive, I want you to notice what's happening to that black curve compared to the red one. All right, and again, we're going to go back to 0. What happens as we make the values of n negative? How does that make that graph shift? And so here you can watch the slider in action. What happens as n changes? How does the graph change? All right, so we have watched how the value of m and n can change the equation. So let's look at this example that I have right here. F of x equals 2 to the power of x plus 3. So the first thing that I notice is that at the end of this, I am adding 3. So because I understand how m changes things, I know that this plus 3 is going to shift this red curve up 3 units. 1, 2, 3. So I'm predicting the new y-intercept should be at 4. So let's see what happens when we click on it. And just as I thought, you can see that every single point on this blue curve is 3 units higher than the red one. Even up here, 1, 2, 3. So every single time, this blue curve is 3 units higher. That's the power of m. Now, if we look at our next example here, this equation f of x equals 2 to the power of x minus 2, this is a change in our n value. So again, remember from our previous example, changing n is going to cause the curve to move to the right or to the left. And so because this is saying x minus 2, I actually know that this red curve is going to shift 2 places to the right. And so let's see what happens here. And again, if you notice this green one is now 2 places to the right of the red one. And the reason that happened is because in the equation, we took away 2 from our exponent. That's all that we did, and that causes that shift to the right of 2 units. So we're going to be checking out our last example now of how we can transform that equation y equals 2 to the power of x. And in this example, you will notice that we've done 2 things. We've changed the exponent value by adding 3. And I know from our previous examples that that's going to cause that red curve to shift to the left 3 places. And I also notice here that we put this minus 4 at the end. So I know what that's going to do is that's going to cause the curve to move down 4 places. So this is going to be a double shift. So we're going to shift to the left 3 units and down 4 units from what we are calling our parent function. So let's close this and let's see what happens. All right, it's very hard to see, so let me zoom out a little bit. But we can kind of see. Let's see, if we take this point, we have to go left 3, 1, 2, 3, and down 4, 1, 2, 3, 4, and that puts me to the same spot on this black curve. So the idea is when you're working on this in IXL today, focus on how these values that we add or take away change where the graph is located. And then also the other part is we want to also think about what happens when we change A and B in that same instance.